Welcome back. In task 11, chapter 9, models of the system. Exercise 9.1. Using the method-oriented approach with the example graphics, the program described in section specify the move operation as a schema which action on the currently selected objects. Is the operation you have defined cumulative? Two successive moves can be done as one move which is the sum of the other two, or is forgetful. Discuss the implication of the framing problem in your definition. Answer. Students may not have a great familiarity with the Z notation used in this textbook, especially if they do not have a computer science background which emphasizes formal specification. Nevertheless, we will provide a model answer to this exercise in the Z notation and leave to the instructor to decide whether an alternative language can be used to express the same ideas. To accommodate the specification of the move operation, we will first need a function which allows us to add two coordinate points together. We just provide the declaration of this function here. Exercise 9.2. Write a similar schemes for resize. It shall have the following formal schematics: the width and height attributes of the shapes bounding box. The resize operation shall make one corner of the bounding box be at the current most position. Height. The width of a box is twice the difference between the x coordinate of the center and the coordinate of any corner. Answer. Structurally speaking, there are some errors in the Z usage for the height in this exercise. The type point is not schema type, and so it is not meaningful to use schema selection. It's an expression like centroids and corners. The other Z students should pick up on this error. However, spirit of the height is still valid. To make things legal in Z, you can change the declaration of point as follows. To best specify the resizing operation, we will require it to explicitly model the bounding box of SF. We introduce a type called bounding box switch. Exercise 9.3. In section 9 to 5, we cite that the specific algebraic Z-draw called the extended to say that M of resize or unselect after other lead has no effect. The axiom for unselect looks like this. Answer. The three additional axioms are axioms 4 and 5 are to show that the axiom 10 is derivable from axiom 4 and 9 we can argue as follows. Move. Exercise 9.4. A two-function calculator has the following buttons: 0 until 9, plus, minus, and this would comprise the command set C of a FIRE model of the calculator. The state will consist of the three components: the two current number being entered, the last number, and the vending operation plus or minus. The display is simply a signed number. For this example, ignore the result. Write down semi-formally the dot function updating the state for each other command, and the display function plotting the state of the current display. To check your definition, what does the display have on it after the user entered? Most calculators will show. So 5 does yours? Consider the display after the sequence and the effect on each additional user input of 3. Does the calculator satisfy the transparency property? Answer. The definition of the doit function called process as follows. We will use the Z notation in the sample answer. The character is set is a definition as Exercise 9.5. Imagine a calculator normal except it display A for O, B E for 0, B for 1 up to G for 9. So the number 372 volt efforts as DHC. Does this affect the formal transparency of the calculator? Solve it. Answer. Formally, this would not affect the transparency property of a calculator any function from display to effect which held for the number would also hold for their alphabet counterparts by just composing it with the code E for 0, B for 1, up to G for 9. Of course, most people will probably find using the encoded calculator quite a bit more difficult than one which uses the normal 10 digits. The important lesson here is a formal expression of the transparency property does not indicate how difficult it is for a human to decide determine the function due to display and effect. The formal expression just requires that there be some function. In practice, human users will probably judge encoder calculator as unpredictable. The moral is that even though we can capture an usability property formally does not mean that we capture the entire intent of the property. Exercise 9 for 6. Can you suggest any improvements to the screen button feedback problem discussed in section 9.4 that will distinguish of the interface between the two cases of hiding or missing the button? Is there any guarantee with your solution that the user will notice the distinction? Answer. Some suggested fix to the button feedback problem will be to have the function attach the button the be invoked when the mouse key is pressing down rather than up, but the solution will not work for function invoked on pop-up menus. Another possibility is to have some visible or audible feedback from the button associated with the invocation of the function of the mouse key release. Thank you.